Okay, girls, so today we're going to be doing chapter 7.5 that is called Technology and Linear Graphs, but really it is focusing on parallel lines and perpendicular lines. So I've decided to call these videos parallel and perpendicular lines. So what are parallel lines? Let's focus on that first. So I'm going to draw a Cartesian plane here. Beautiful. So this is the y-axis and this is my x-axis. Beautiful. Now parallel lines, and you know this from year 7 again. Sorry girls. Parallel lines are lines that do not intersect. Agree? So I'm drawing here a line, any line. I'm going to do it as big with a positive gradient. Agree? And I'm going to copy and paste it. Oops. And I'm going to put it next to this one here. And I did that so that I can make 100% sure that I know that they are never going to intersect. And if I paste it again, it's going to come out. Then let's put it here. And I'm going to put this one purple. There we go. There I have 3 parallel lines, which I know that they're never going to intersect. Okay, so if I call that the line that I have here in blue, I'm going to say that this one is y equals m1 times x plus c. Okay, oh, c1, let's say, whatever that is, and then this green one here that I have here is y is equal to m2 x plus c2, and then my purple one that I have here is y equals m3 x plus c3. What I know is that all of them are intersecting at a different point, so c3 is not the same. Agree? C3, like the y-intercept, is not the same to any of them. Okay, because they're intercepting the y-axis at different points. Agree? But what I do know is that their gradient is the same, and actually that's going to be the definition of parallel lines. So when there are parallel lines, they never intersect. It's important that you write that in your notes. They never intersect, and their gradients are going to be the same. So m1 is going to be equal to m2, and is going to be equal to m3. Okay, so the gradients are going to be the same. Wonderful. So that's the definition of parallel lines. Now, if we talk about perpendicular lines, so perpendicular lines have to create, I'm going to delete this. Should I delete it? Should I make it smaller? I don't know. Let's make it smaller. Oh, no, that didn't work. Okay, I'm going to bring this down. So perpendicular lines, they do intersect, but they intersect at a very important angle, a characteristic angle. So what happens with perpendicular lines is that they intersect. My goodness me, sorry girls. Whatever, I'm not going to fight it. So perpendicular lines do intersect, but they form, when they intersect, they have to create an angle of 90 degrees. Okay. So if I draw smaller Cartesian plane here, and I have that this one is y and this one is x. I can insert two parallel lines. Let's see if I can rotate these ones. No, I can't. So what I'm going to do is I'm going to create, but I want to rotate it here. There we go. So, and this one I'm going to put a different color. Let's put this blue. So if I draw a line following this one, I just wanted to make very sure that I had the 90 degrees. There we go. And then with a different color, let's say purple, I draw the other one. Are they the same color? Oh, yes, because I changed this one. So this one, let's put it in dark blue, or maybe green, so it's easier to see. There we go. Beautiful. So there we go. We have there two perpendicular lines, and I made sure when I drew it that I was 100% sure that this was a 90 degree. So what happens with these ones, the characteristic, the important characteristic is this one. If this one is going to be equal to y equals an m1 x plus c, and the purple one is equal to y equals to m2 x plus c2. Forgot to put the c1 here because they don't intercept in the same point either. Agree? In the same y, they don't have the same y-intercept. That's what I meant. The relation between their gradient is that if I do m1 times m2 is going to be equal to -1. So in other words, one is going to be the reciprocal of the other. So if I do an example here, when I say that one is a reciprocal of the other, what I mean is that, let's say that if m1 is equal to 2, or in this case, let's say that it's -2, then m2 will have to be positive, because this one is negative, and we can see this one is negative, the other one has to be positive, and 1/2 is the reciprocal. So when I do that, you can see, if I'm going to test our rule, I can say, okay, 2 times -2 times 1/2. If I do that multiplication, I can cancel this out, and that's equal to -1. So they are, if that's the case, then those two lines will be perpendicular. Okay, wonderful. Now we're going to be doing some exercises, questions that are also theory. So I need you to take note of these ones in your book.